Now the next exercise is calculation of strength properties. Among strength properties, we divided unconfined compressive strengths, UCS, tensile strengths, TSTR, and friction angle, FANG. To calculate these parameters, please open the strength properties in a Geomechanics tab. Note that there are three parameters: UCS, FANG, and TSTR. Now let's use usual methods for calculation these parameters. For UCS, we will take Horst's relation from VP. More information you can find in user guide. All equation will describe here with reference, with unit. Okay, this is correct. UCS maybe right, or Sarud. Okay, then internal friction angle, let's take LAL relation from VP, curve name FA LAL, and tensile strengths. Let's take usual methodics, as an TSTR is equal 10% from UCS. This is user-defined function, 0.1 multiply UCS. Okay, we will return to TSTR when we will calculate UCS, and this parameter will be in this list. Now let TSTR will be not active. Okay, now let's calculate. Please move on well section UCS and FANG. Now we will check these parameters with correlation on core data. For calibration of UCS by Horsroot, we will use unconfined compressive strength by core and friction angle. Now, okay, let's show the mechanic phases and stratigraphy column. Okay, now we see that for lower layers there is a good correlation. Only in the 2 points not correlated with curve, but in a BA layer there is no correlation. It can be explained that BA, this is Bajen's suite, this is unconventional formation where there is no correlation, and traditional correlations don't work. Therefore, we have to find another correlation to BA layer, and we will do it now. Yes, we will try recalculate curve UCS Horsroot now. Okay. Yes. We will now internal friction angle will be not active, and we will use stratigraphy. Okay, let's remove all layers and leave only BA. For BA we will be use another correlation. Let's use user defined. Now let's write the Horsroot equation here by 0.77 multiply okay, and press preview. Okay, now we see that it did not change. Let's do the iteration. Let's change coefficients, maybe to preview, not good, maybe 3. Yes, it's much better. Okay, then now we press run, overwrite elements. Now let's check friction angle. Because of difficulty of definition of friction angle by passport, by failure more envelopes method, there is admit weak correlation between core data and curve, and now I prefer leave this curve in current view, and at last let's calculate TSTR. Now we will open the strength properties, deactivate UCS and friction angle, and tensile strength will calculating as 0.01 multiply UCS Horsroot. Okay, TSTR, run. Now we will see TSTR here, and let's calibrate on curve data, core data. Not good. Let's use another coefficient. Calculate curve. Then maybe 0.15 preview. Much better. Maybe 0.02. Okay, this is very good. This is much better than initial. Okay, now let's run and overwrite elements. Okay, in this exercise we have calculated UCS, TSTR and friction angle.